Hi everyone, welcome back to the channel. This is Rosario Borgesi and in this video I want to talk about the splits control. This set of protocol allow us to split funds and also revenues in a very straightforward way. So instead of sending our funds to a specific address, we will send them to the smart contract that automatically splits the revenues across multiple addresses. So let's see how it works and let's get started. So splits is a set of composable, open source, and audited smart contracts that make it easy um, to share earnings in a crew of people, for example, so to manage on-chain revenues. These smart contracts are running at exactly the gas, and they charge no protocol fees. And of course, this structure, this protocol of smart contract will run forever, and there is no need for trusted third parties of or maintenance of any kind. So this is an example of a structure of a split contract. As you can see here this is the smart contract that we are going to deploy, and this allows to share the revenues between these three addresses. In this case, the address of Alice, of Bob, and here there is also another example. For example, here we can put another split smart contract as an address, so this revenue here can be split among these two recipients. So the main features of this protocol are that it is free, so it runs exactly at gas cost. It is unstoppable, of course, because since these smart contracts are non-upgradable and they are deployed on the blockchain, which is immutable, they run forever. And it is multi-chain, of course, because a smart contract that is compatible with the EVM, so with the Ethereum layer 1, can be also deployed on Optimism, Base, Polygon, Arbitrum, or whatever chain, or layer 2. It is EVM compatible. It is open source, and all contracts are verified and audited and publicly available on GitHub. And so it is also composable, so each contract can have a payable address and can receive Ether or also ERC20 tokens. This is important if we, for example, want to receive or transfer USDC, USDT, whatever. It is efficient because it allows batched operations that maximize the gas efficiency. So of course it is on chain, so as a blockchain definition there are no third parties APIs or external dependencies. It is fair because the distribution costs are shared, and also it is automated. This is the this is this stack or this protocol has been also utilized by various platforms. For example, here Zora or here Protocol Guide. There are a bunch of players that are have used this protocol, and it is today we will see the split V1, so the main the basic set of splits smart contract, but there are also various other kinds of contract. For example, there is also the liquid split that allows the split process to happen by means of NFTs. So, like the shares of a stock, to make a comparison. But today, as I said, we will focus on the basic smart contract. So this is a basic split smart contract. As you can see here, we deploy the smart contract, and here the balance is distributed according to the earning share, the percentage share of each address. So, for example, this address here has a 40% share, this other has a 60% share, but the protocol is not fixed to two recipients. We can put as many recipients as we like, and we can also set um, the share here, percentage share as we like. And also, as we said before, we can also distribute Ether or also other ERC20. So it is a very, very interesting project. Another thing that I wanted to show is that you have also the possibility that there is also a front-end application by means you can deploy contract. For example, here there are all kinds of contract. For example, in all supported chains. For example, here you can deploy split smart contract. Here can specify the recipients. Here the percentage of the share. Here the controller address. So you can use um, this user interface, or as we will see, we will do it programmatically using the SDK. But an important thing to do here is that before starting anything, you need to set an API key. This can be done here. So you have to give them your address, and you can create the API key. I've already created it, so here you can do it in this by hitting this button here. So I would start to create a new project and then try all these the function that are provided to us uh, by the SDK. By the way, I forgot to tell that here there is the documentation of the SDK. So as you can see here, there are a bunch of functions that we can we will explore a small set of them just to give you the basics. But you can do pretty much a lot of stuff here, and also here you can also check out the GitHub page of the splits contract, so you can check here all the code. And another thing that you can do here, there are maybe some examples if you want to check them out. No, this is this brings us to, yes, here there are maybe some splits donation. There is this should be an example of a project of a smart contract that is running right now, so you can check it out if you like. And so let's start creating uh, a new Node.js project and try all this stuff out. I will use WSL2, but you can do the same thing with Mac OS or Linux, because the process it is the same. So let's create a new directory, call it splits. Let's open it. Let's change directory, and let's start a new Node.js project. Okay. Let's start install uh, the first dependencies that we need for any basic Node.js project. Okay, so let's open it in Cursor. Let's create a new file tsconfig. Let's create a new folder src. Let's put it inside the new file index.ts. And let's write a simple console log. Let's add the type module in the package.json. Let's add the main property. Okay. We just need to modify it. src slash index.js should be fine. Let's add the script dev to run the code. Okay. Also, let's add the start script. Is the same as the dev script. Okay, now let's run the project. npm run dev, run start, sorry. Okay, it works. Let's add the dependency of the splits SDK. On the split site, we can create on the settings, we can create the API key. Now we need to create a .env file to store the environment variable. The first one is the private key of your Ethereum wallet. And the second one is the RPC URL. Create this RPC URL, we can go to the Coinbase developer platform, go to intersection node, and we can get the RPC endpoint. In this case, it is for the base mainnet, but we will use the one for the testnet Sepolia. Or otherwise, you can also get it from Infura. There are many providers to get this RPC URL. Okay, also here you sign in, get the API key, it is the same thing. Okay, then you have to put the splits API key. Okay. As we said earlier, you can get from the settings create API key in the splits website. I will put mine and of course I cannot show them and you put yours and then uh, we will resume the tutorial. Now let's add the VM dependency that allow us to interact with the blockchain. Let's start by creating a new account from the private key that we have put inside our M file. Let's import the function private key to account from VM accounts. Okay, this must be cast as a 0x string. Let's console log this account. Let's run it. Okay, here there is an error because we haven't imported the .temp the .temp config. Let's run again. Okay, fine. This is my account. It is working. Let's start by creating a public client that is used to read the information from the blockchain. Yes, before we need also to specify the chain that will be base Evolia in our case. Let's put it in uppercase. Okay, we need to pass the chain. Then we need to pass the transport property. We import the HTTP function from VM. We pass it the RPC URL of our in our .m file. Let's import create public client from VM. Now we need to add a wallet client that allow us to write in the blockchain. That should be fine. The suggestion from cursor. Let's import this function create wallet client from VM. Now let's create a new splits client. We need to pass here the chain ID. We pass also the public client, the wallet client. Okay, this can be removed. Then the API in the API config we pass the API key that we have gathered from splits. We import the splits constructor, splits client constructor. Okay. Okay, here there is maybe some problem with with the library because I already had this problem before. Let's add a check for all the environment variables so to make sure that they are all they have been all populated. We move this chain up. Okay, here we write required env Okay, this suggestion from cursor seems fine to make sure that all the environment variables are correctly populated and are present and are not blank. There were some problems with the library VM, so I've put the version 2.0.0 and the errors have disappeared. So here I put dot split v1. Let's create a new function, create split to create a new split smart contract. Let's put the arguments. Here there are two recipients. One is the address that ends with 3df, and the other is my with a percent allocation of 50%, and the other is my account. My account with a percent allocation of 50%. Then we have put a distributor fee percent of 1%, and as controller my address, account.address. Okay, these are the arguments. Of course, you can put how many recipients as you like. These are just two, but the sum must also be always be 100%. Let's call the function create split to deploy this new smart contract. Let's console log the response. And let's also return the response. Let's create a new main. Here we just call await create a split contract. Here we add dot catch error. Console.error. We just console the error. And process.exit one, just to make the code a little bit cleaner. Let's format the document. Let's run this code. npm run dev. Okay. Seems that everything went fine. It has created this split address. Let's copy it and put it in a constant. Let's check this smart contract on base scan. Base evaluate scan. Okay, so you can see here we can see the code because the smart contract is verified. Here we are calling, here there is the split wallet smart contract. And we are basically calling the factory of this splits contract that allow to create more splits contract. So that's why it is verified. Here we can see all the function related to this smart contract. Update the splits, create the splits, so on and so forth. Okay, now let's check. Let's call the distribute token function because in order to let's put here a receiver. Here we add the arguments. The first argument is the split address. Then we have the token address. We put the zero address because here we want to distribute Ether. We need to import it from VM. If we want to import another type of token, we need to specify another its address. For example, we can also distribute ERC20 tokens. Here we put as a distributor my address. So the receiver, sorry. Let's format the document. Let's call the distribute token function from the splits client. Let's console log the response. Okay. In reality, we first need to check the balance before we can distribute the token. So let's check that first. Let's create a new function, get splits balance, that receives an address type string. Let's create the args object. Let's put the split address contract, the token, which is a zero address because we are checking the balance, the ether balance of this account. Okay. Let's call this get splits balance function from the splits client, and let's console log the response. Okay, we retrieve the balance from the response. Then we need to format the balance, and we call the function format ether. We import the function format ether. Here there is a little typo. The argument in input is not required because we will not use it. We just need to put the split address constant. Okay. Let's run it. Let's call this function npm run that. There is a little error here. So the error was due to the fact that this property was a token, i.e. there was written badly. So I have fixed it. Now let's run this application. Okay. The balance is zero either, of course, because we haven't sent any funds to this smart contract. Let's connect to base Evolia and send some ether to our smart contract, to our split smart contract. I will send them from my first account. Let's paste here the address of our splits contract. Okay, let's send 0.001 ether. Continue. Confirm. Okay. Let's run the application again. As you can see now, the balance of our address, it is 0.001 ether. Okay, now in order to distribute the token, we need to call before the distribute token and then the withdraw token on the same address. We are doing it for a single address this way, so we are withdrawing the funds for the address that ends with the 3DF. Then we will do also for the other account of the splits contract. Okay, we have already created we can already call the distribute token function. This is the address that we want to for which we want to distribute the token. Okay, we can run it. Okay, this is the address. As you can see, it has a 0.0221 ether. Copy. Let's copy this value. Let's save it. Let's put it inside a comment. So we can check the balance before and after the withdrawal process. Okay, let's run this application. Okay, seems that have been went fine. Okay, here it has logged the event. But now that we have called the distribute function, we need to call the withdraw function. Async function, withdraw token, withdraw funds. Let's create the args object. Let's put the address, which is the receiver. Let's put the token, which will be zero address because we want to withdraw. No, sorry, here there is an array. We put zero address because we want to retrieve ether. Let's call the withdraw function, withdraw funds. Okay, console log the response. Let's comment out this must be called after distribute token. This must be called before the withdraw function. Sorry, withdraw funds. There is a misspelling here. Okay. Let's call the withdraw function. Let's put this line on top. Let's run the application. There is an error. Okay, it seems that it has called correctly the function. Let's check out the transaction. As you can see, it says send 0.000505 Ether from the smart contract to my address 3DF. Okay. We can also check it on MetaMask. As you can see here, if we copy this balance, so the balance is 0.0225. And since it was 0.001, uh, it has been split in half, so it is correct. 0.0226. Okay. Okay, this has been done for the first address. Let's do it also for the second address. We can call this function one after the other. The other address, it is this one, 83D. Let's check it also on MetaMask. Scope it. It is 0.071 Ether. Let's copy the two functions. Let's put account.address. Here there is a typo. It should be funds. Okay, withdraw funds. Now it should withdraw the funds right away. Let's run the application. It seems that it went fine. Okay. Let's check the balance. Seems that it has not been updated yet. Let's check out the transaction. Okay, perfect. As you can see from the smart account has been sent 0.0000495 Ether to the address 83D. This number it is because it also accounts for the gas fee. Now it has been updated 0.0715. So the balance of 98 3D is 0.0715 it. So it has been increased of 0.005. Okay. Now, if you go on the splits contract, you can see here all the function that you can call. We have called the withdraw funds and distribute the withdraw funds, but here, but you can also call them in one shot with the function batch distribute and withdraw, but you have to that perform some multi-call transaction. You can distribute multi-tokens on a split and withdraw for a given address. So you can specify the recipient address that you want to withdraw the tokens from for instead of doing it calling singularly the two function distribute and withdraw. Of course, here you specify the recipient addresses and you can also specify multiple tokens, or for example, a single recipient address. And of course, you can also do it for all the addresses of the splits contract in one shot with the batch distribute and withdraw for all function. And also here you can specify the various token that you want to withdraw. So thank you for watching. I hope that you have learned the basics of the splits protocol. If you have any questions, please drop a comment below and see you in the next one.